polynomials, and the first section is a review over exponents, and when you add and divide or multiply and divide exponents with the same base, what the rules are. Okay, so as an example, I have 3 to the 6th times 3 to the 8th. This only works when the base is the same. Okay, and when I say base, this number is the base, this number is the exponent. Okay, and it only works when the bases are the same. Okay, so what I could do, 3 to the 6th is just 3 times 3 times 3 times 3 times 3 times 3. Right? This is the shorthand way of writing this. Okay? And if I'm going to multiply it by 3 to the 8th, that's going to be 8 more 3's. You three are the only ones I'm teaching right now, and you're the ones that aren't watching what I'm doing.
I'm mad because I drew on the board.
Okay. So what do I have here? 3 to what power? How many 3's do I have? 14, right? So this shows that if I have the same base with exponents, I add the exponents. Okay? So this is 3 to the 14th. Okay? If I took 3 to the 8th, let's make it something smaller, and divided, okay? Yeah, because this is 3 times 3 times 3 times 3 times 3 divided by 3 times 3. So this cancels with this cancels with this, and I'm left with 3 to the 3rd power. And I get that by subtracting 5 or 2 from 5. So this is the same as 3 to the 5 minus 2 power, which is 3 to the 3rd. Okay. If I have an exponent raised to an exponent, I multiply the exponents. I don't add them. Okay? And this is because 3 squared is 3 times 3, and I want to do that 3 times, right? 3 times 3, 3 times 3. So how many 3's do I have?
6.
3 to the 6th power, which is 2 times 3. Okay? So this is 3 to the 6th. So the rules are, if I multiply something with an exponent with the same base, I add the exponents. If I divide, I subtract. And if I raise it to a new power, I multiply those exponents. Okay? So I'm going to do a couple of examples real quick. Let's do this one. When I have an exponent on the outside of the parentheses, it applies to every item inside. So 5 to the 7th power is what? Is that right?
Yeah.
And then a to what power? What's left here? A to the what power? What do I do to the exponents? Yes. And then b to the 28th power, because 4 times 7 is 28. Okay. Let's do one where I need to simplify first. Well, let's just do this one. 5 r to the 6th raised to the 4th times 1/3 r to the negative 2 to the 5th. So what do I do first? 5 to the 6th power?
Can't you combine like terms?
Oh. Because they're being multiple.
Okay, parentheses always come first.
Yeah.
So I've got to do what's in this parenthesis first. It's being raised to this 4, right? So it's 5 to the 4th, r to the what power? And multiplying this times 1/3 to the 5th, r to the what power? Negative 10. Okay, so what's 5 to the 4th?
625.
Okay, so this is 625 r to the 24th. What's 3 to the 5th? 3 to the 5th. Thank you. So this is 1 over 243 r to the negative 10th. So now what I'm going to do, I've got 625 times 1 over 243, right? When I multiply this times this, it's this. I can worry about simplifying if possible later, but for now that's what the fraction is. And then what do I do with the r's? The exponents.
Combine them.
How?
Subtract 8.
When I multiply two of the same base with different exponents, what do I do to the exponents? Huh?
You add them.
Add them. So it's 24 plus negative 10.
14.
So that's how this gets simplified to this. And if I can simplify this further, I should. Not sure I can. Okay. Let's do another example. X to the 4th, y to the 4th. Okay. So on something complicated like this, just start with the parenthesis. Okay, 2 is not being raised to the second. So I'm just going to rewrite it. X to what? 8th. Y to the 8th. And I'm going to divide that by 2 to the 4th. X cubed. Y to the 5th. Z. Okay, so let's just concentrate on this and worry about this in a minute. So 2, really this is 2 to the 1st, right? So one of these cancels with this, and I have 3 left, right? 1 minus 4 gives me negative 3, which is in the bottom, okay. So I have 1 over 2 cubed. That's what these cancel to be. Does everybody see that? No, because, well, this is 2 on top, 2 times 2 times 2 times 2 on bottom. This cancels with this, and I'm left with 2 cubed on bottom. Okay, we'll talk about negative exponents tomorrow, and it'll make more sense, but for now, this is this. Now, x to the 8th over x cubed is what? Okay, and it's on top. Y to the 8th over y to the 5th. And then I have z on bottom, and it doesn't cancel with anything. So this whole thing simplifies to this. Okay, let's go ahead and simplify this before we worry about the division. So we have 8 on top, 32 on bottom. So that's 1/4. X to the 10th, x to the negative 2. What do I do when I divide? Subtract, which is 10 minus negative 2. 10 plus 2 is 12. And then I have y to the 5th on bottom. Right? Okay, so this simplifies to this, but I'm dividing it. So when I divide a fraction, I flip it and multiply. So I'm going to multiply this by 4y to the 5th over x to the 12th. Okay? So this 4 and this 2 to the 3rd, what's 2 to the 3rd? No. 8. So this is really 8. 4 and 8 is 1/2, right? So this goes away and this becomes 2. Now I have x to the 5th here and x to the 12th here. What do I do? Subtract. 5 minus 12 is negative 7. This is bigger, so it's x to the 7th in the denominator, right? Because if you can imagine, I've got 5 x's on top, 12 x's on bottom. The 5 cancel, I'm left with 7 x's on bottom. Okay? So I have, this is gone. This is now 7. And then I have y cubed, y to the 5th. What do I do with those? Add them. So that becomes y to the 8th. I have 2z x to the 7th. So that mess simplifies to that, just step by step. Okay, so let's look at the textbook check. Four cubed is 4 plus 4 plus 4. False. It's 4 times 4 times 4. Question 2. 3 to the 4th plus 3 to the 5th.
3 to the 9th.
Well, 3 to the 4th times 3 to the 5th is 3 to the 9th. I think this problem is written wrong. It should be a times.
It was 3 to the 9th.
Yeah, so that's not plus though. Because if I took, so that's my fault. If I took 3 to the 4th and I added 3 to the 5th, I get 324. 3 to the 9th is 19,683. Okay, so that should have read, what's 3 to the 4th times 3 to the 5th? I'll try and get that changed before 4th period. Okay, so yes, if that were worded correctly, it would be 3 to the 9th. 5 to the 9th divided by 5 to the 7th. Subtract, so it'd be 5 squared. If I simplify that, well, it would be 8, because 2 to the 3rd is 8, a to the 9th, b to the 12th on the bottom. So it's this one.
I'm pretty sure I put that one.
8, a to the 9th, b to the 12th. Do you have your quiz up where you can see?
Oh, no.
Okay. And in question 5, in the second video covering the product, quotient, and power rules, James Sousa also states that a to the 0 is 1. True. Okay.